first thing we're going to learn about Swift is the basics. And this actually covers a lot of the things that other programming languages cover, because Swift takes things from different languages. So for example, here, constants and variables. We use the keyword let to create a constant. For example, my name is Pablo, that's a constant. I don't plan on changing my name anytime soon. Now, a var is a variable. So my age is 18, and that's a variable, and that could change. So we're using here the print statement to print my name, and when we run the code, we can tap on that little ABC part and it says Pablo, that's my name. So if I were to print my age, run the code again, tap on that little ABC, my age is 18. Now if I were to say my name equals my name plus Cortez, you cannot assign a value to my name because it's a constant. So let makes it a constant, it makes it not mutable, it makes it unchangeable. So now let's talk about type annotations. If I were to make a variable called welcome message and make sure that's a string, so I use type annotations to make it a string, and then just add a message of hello, then the computer knows that it's a string. There is no doubt about that. Even though it can do it itself, we are making it explicit that we want it to be a string. So now if I make another variable and I call it red, green, and blue, what I'm doing here is I can declare multiple variables if they're going to be the same type, in this case double, in just one line. So if I wanted my RGB values, I could have them right there. So now let's go more in depth with printing, and specifically string interpolation, which is a very, very cool feature. So this is what string interpolation is like. So if I were to write or print out a message, like my friend would like to say, and then whatever, I can put an expression inside those parentheses. For example, welcome message, the variable welcome message, which has hello in it, and it will print out my friend would like to say hello. This is a one-line comment, and this is what's called a multi-line comment. And what multi-line comments allow us to do is, like specifically in Swift, is that we can have nested multi-line comments, which allows us to have one comment inside another comment. Now what we're going to talk about are semicolons and how they can be used. So for example, let's say I create a variable called cat, and what I'm showing here is that we can actually use Unicode characters such as emojis in order to assign them to a variable, or they can actually be the name of the variable depending on how we're feeling that day. So we can have a dog and it's equal to the dog emoji, right? And so the way semicolons work is that they're optional, they are not required, and we can also use them for one-line declarations. So for one-line declarations, what I can do is I can use semicolons to separate lines or statements. So I can write var foo equals x, semicolon, and then var bar equals y, and I don't need a semicolon after that. But what the semicolon allows me to do is actually have two statements in just one line, and that is the only reason where it would be necessary to use semicolons, because otherwise they are not necessary. Integers are whole numbers with no fractional component, such as 42, for example. Or we can make a variable called the distance to Starbucks and make that equal to 11 or 12 or whatever. Now we're going to talk about integer bounds. We can access the minimum and maximum values of each integer type, whether that's integer 8, integer 16, integer 32-bit. It depends on what type of operating system we're working on, and we can use whichever one we want depending on the memory allocation we want to give to it. So for example, if I make a var and call it min value, I can access its min property and its max property as if I was just using any other property in any other object in a programming language. So Java would use this notation, C++ would use this notation. So I can have the min value and the max value, and if I run the code, I can see that these are -128 and 127 respectively, and these are the values by which they are bounded. Integers are either signed, which means they're positive, 0, or negative, that means they have a sign to them, or unsigned, which means they're just positive or 0. The second type we're going to be looking at is the floating point, which has two types that we can use in Swift. We can either use a double or a float. So for example, let's make a double called my double and set it equal to 13.2. This is a 64-bit floating point, and if I were to make a var called my float equals, let's say, 3.14, that would be a 32-bit floating point. So what that means is that a 64-bit floating point allocates 15 decimal points. It's precise to 15 decimal points. A 32-bit floating point, so for example, if I use a float, then that would only make it precise to 6 decimal points. The Swift guide recommends that we use floats as little as possible as opposed to doubles. We should always use doubles if we have to. So now we have what's called numeric type conversion, and we can use, for example, integer conversion. So let's make an integer pi, set it equal to 3.1415. And if you see, I have written int and then parentheses, and I've put a value inside those parentheses. What that does is that it knocks off all the decimal points after the 3 and leaves a 3 stored in integer pi, because integer pi, the type of integer pi, is integer, so it will only store an integer. That means it cannot store any decimal points. So the value of integer pi, if we run this code, will be equal to 3.